Hey, today we're going to talk some more about Chapter 9 energy, and we're going to talk specifically about potential energy and kinetic energy, which, when looked at together, are called mechanical energy. Potential energy and kinetic energy looked at together would be called mechanical energy. Potential energy is simply stored energy that's not been used yet. Remember that energy is the ability to do work or to cause a change in an object. So how do objects get potential energy? Well, by doing work on them. Remember in ours, who was the most powerful student activity? When you guys walked up the stairs, were you doing work? Yeah, you were. In fact, you calculated the work by taking your weight in newtons times the distance or the height that you walk. Okay? That's exactly how much you increased your potential energy. Imagine if you were at the top of the stairs and you jumped off the back and landed on a cardboard box. Would work be done on the box? Yeah, work would be done on the box, and it would be ideally equal to the potential energy that you had at the top of the stairs. There are some forms of potential energy that we should talk about, some different forms. The one we were talking about on the last slide is known as gravitational potential energy. Sometimes they just call it GPE, and that's because the work is being done by or against gravity. Some other forms, elastic potential energy, when you would either stretch or compress a spring. Some examples of elastic potential energy might be if you stretched a rubber band and then you shot it at something. Stretching that rubber band, you would be doing work on it, and when you shot it, that work, which was really then changed to potential energy, would eventually be changed to kinetic energy, which we'll talk about kinetic energy in a few slides. Other examples of elastic potential energy, a bungee cord. Okay, if you do a bungee jump, that elastic bungee cord is stretched, you do work on it, it now has elastic potential energy. Chemical potential energy is another type of potential energy, and that has to do with the potential energy that is stored in bonds. And when you break these bonds, energy is released. Example, food. When you eat food, your body digests that food, and in the process, it breaks bonds between the molecules of the food, and energy is released, and this helps sustain you. Or another example of chemical potential energy, think about gasoline. Okay, lots of energy in gasoline. You can release that chemical potential energy, breaking bonds by igniting it, and then that energy can be used to run a car, let's say. So how do we solve problems on potential energy? We're always solving problems in physics. Potential energy, like we said, is equal to the work done, and work equals force times distance. So therefore, we would say potential energy equals force times distance. Or in the case of gravitational potential energy, it would equal weight times distance. Remember that weight is equal to mass, m, times acceleration of gravity, g, or simply m times g, where g equals 9.8 meters per second per second. Distance would really be the height since you are lifting the object. So from all of this, we would get that GPE, the gravitational potential energy, equals mg times h, and it would be measured in joules. Here's a sample problem. Let's say we've got an object. It's got a mass of 5.4 kilograms, and we want to raise it a distance of 55 centimeters. The lists are given here. Notice there's an asterisk by the height, because when we do potential energy, or work for that matter, the distance needs to be in meters. So we convert that 55 centimeters to 0.55 meters. Our formula, GPE equals mgh, and just stick the numbers in, and we wind up with GPE equals 2.97 joules. The other type of mechanical energy that we talked about, or I mentioned, is kinetic energy, and this is energy that's due to motion. Every moving object has kinetic energy, and we can calculate it very quickly by using the equation kinetic energy equals 1/2 m, where m is the mass, times v squared, where v is the velocity of the object. Kinetic energy is also measured in joules. So now we have three things that are measured in joules: work, potential energy, and kinetic energy. Let's go back to the stairs activity for a minute. Okay, we said that you had potential energy when you were at the top of the stairs. And if you jumped off the stairs and landed on a box, you would do work on the box. As you move downwards, your potential energy is changed to kinetic energy, and right before you hit the box, all of your original PE has been changed to kinetic energy, and now that kinetic energy is going to be used to do work on the box. Here's a sample problem for kinetic energy. We've got an object, mass 7.2 kilograms. Mass needs to be in kilograms when you're finding energy. Moving at 23 meters per second. Velocity needs to be in meters per second. Find the kinetic energy. Okay, we list our given, list our formula, Ke equals 1/2 mv squared, and you can see the work. Okay, the final calculation gives us 1904.4 joules. Note here that 1 kilogram meter squared per second, kilogram meter squared times second squared is a joule. Also note that we really haven't paid attention to significant digits. Do you know what the significant digits should be in the final answer? They should be, in this case, 2, because our given, the smallest number of significant digits is 2, so we would want 2 significant digits in our answer, so we would round that answer to 1900 joules. Here's another kinetic energy problem. Let's say we have a motorcycle, has a kinetic energy of 25,000 joules and a mass of 200 kilograms. What's its velocity? Well, this one's a little bit different. We're asking you to find the velocity, so you're going to have to change some things around. Once again, we list our given, we list the formula, Ke equals 1/2 mv squared, but now we're going to solve this formula. We're going to solve this formula for v squared. So in order to do that, we have to get v squared all by itself. We multiply both sides of the equation by 2. That'll get rid of the 1/2. And then we're going to divide both sides of the equation by m. So we get v squared equals 2ke divided by m. To find v, we take the square root of both sides, which gives us v equals the square root of the quantity 2 times the kinetic energy divided by the mass. Plugging these numbers in, over on the right-hand side, we can see that v comes out to be 15.8 meters per second. Okay, there's an important theorem that says, the work energy theorem states that whenever work is done, energy changes. Well, what does this mean? Well, what it means is that, let's say when you climbed up the stairs, okay, did your energy change? Well, yeah, you were doing work and your potential energy got bigger, okay? Now, how about if you jumped off the back of the stairs, okay? Well, eventually work would be done on the box at the bottom of the stairs, and would your energy be changing? Yeah. So that's what this says. There is a video about that explains this. It's kind of an interesting video, and we're going to see if we can play this. Hang on, let me go back. We'll see if we can play it. Sorry for the delay here. Right now. Pressing a spring would be an example of elastic potential energy. I don't think this is going to work. That was pretty funny.
Business phone systems don't have to be expensive or hard to install and maintain.
Sorry about that. Okay, hopefully we're still recording here. That video was kind of a funny example of potential energy being changed to kinetic and how you can have different types of potential energy. What to do now? Well, I'd like you to go to your Edmodo account and open the Google form named Potential and Kinetic Energy PowerPoint Physics 1. Answer all questions and then submit. Okay? Have fun with that, and if you're having any problems, please see me. See ya.